Hello everyone, this is Kiran Kumar BK. Today in this video I am going to explain how to design a flexible payment using the IITPAVE software. So let's get started with the video. Firstly we need to open the IITPAVE software. After opening this, you can see this window. In this window there will be the parameters like number of layers, elasticity modulus, position ratio, Newton's wheel load which is expressed in terms of Newton, tie pressure expressed in terms of megapascals, analysis points, depth and radial distance. This IITPAVE software was developed just to check whether the design of the flexible pavement done is accurate or not. See, in this figure you can see a typical cross section of a flexible pavement, which gives us information regarding the thickness of each layer like STBC, BM, GSP and WMM. This this is done by using a normal conventional CBR method. Normal conventional CBR method is used to design this flexible pavement. Now in this IITPAVE software, what are we going to do means we are cross-checking or we are analyzing whether the design which we have done using a normal CBR method is correct or not. So let's get started with the video. So first column is it is asking us what is number of layers. Number of layers means here we need to consider number of layers. So there are how many layers? 1, 2, 3, 4. So there are totally 4 layers. But what we will do means we will consider GSP and WM as 1, STBC BM as a 1 layer, and another layer is subgrade, which is C. This is subgrade as 1 layer. So there will be totally 3 layers. So 3 layers. Modulus of elasticity for BM STBC, elasticity modulus for GSP WM, and elasticity modulus for subgrade. Position ratio, thickness and thickness. So you can notice that after changing it from 1 to 3, there is a column called thickness which got visible. So this is thickness. I'll explain in the later part of the video. Now let's start what we are supposed to enter in the elasticity modulus for first layer. So this first layer is basically for the BM and STBC mixes, for the bituminous mixes. That's from top we are coming to bottom, BM STBC mixes. So from where we can enter this value means we can enter the value by using the code, that is by code book, this IRC 37 2018. This code book will give a brief discussion brief description regarding the design of a flexible pavement using IITPAVE software. So in this code book, page number 31 will gives us the resilient modulus or elasticity modulus of a bituminous mix, namely BM and STBC. Both resilient modulus as well as elasticity modulus are one and the same. So generally what will happen means for any mixes like BC or DBM or BM or STBC, the temperature at which the annual pavement temperature will be recorded. For say about at what temperature we are laying the concrete. Say if it's in very hotter places, if it exceeds above 40 degree means the elasticity modulus will be low. Relatively, if it is less, it will be relatively more. So say for instance, if we are doing in a place near Karnataka means we are considering the range of 30 to 32. So for a mix of VG30 at 32 degrees Celsius, we can arrive at a conclusion that bituminous mix resilient modulus of a bituminous mix will be in the range of 1800 to 1700 by interplotting. We need to interplot it. So by interpolation I am arriving at the mix is about 1700. So now let's after completing of the BM and STBC, let's go with WMM and GSP. So it's WMM and GSP. What is elasticity modulus for WMM and GSP? So again we will go for codebook will give us the explain in detail. We can enter the elasticity modulus for the second layer by applying to this formula. Resonant modulus for GSP layer. GSP layers, which means it includes both GSP as well as WM layers. So modulus of resistive resonant modulus for GSP. Here there is a formula. For this formula we are supposed to apply. What this formula state means, modulus of resonant modulus for GSP means 0.2 into H. H means the thickness, the total thickness of both GSP and WMM. Here in this figure the total thickness is about 100, 150, 250. So it will be about 400 in to the power of 0.45 into MR support. MR support is effective resilient modulus of the supporting layer. Effective resilient modulus of a supporting layer, which means the resilient modulus of the subgrade. So in order to arrive at the second layer, elasticity modulus of second layer, we need to be aware of the modulus of elasticity of the third layer, which is nothing but the modulus of elasticity of subgrade. Here in this code book itself, we will get the what is the formula, or what is how we can enter for that value. Here, okay, here two formulas are given to find the resilient modulus of a subgrade. One states that modulus of resilient of a subgrade will be 10 into CBR if the CBR of a soil is less than 5. Okay. Secondly, the modulus of resilient will be 17.6 into CBR to the power of 0.64 for CBR greater than 5. Remember, for any road the CBR should be greater than 5. In order to design by using a CBR, normal conventional method, now the CBR should be more than 5, otherwise it will not be possible. So here in this so design, the CBR value is in the range of 9. So what same formula I am applied in the by using the Excel, I am applying here. So what will be the modulus of resilient value? That is 71.815. This will be the modulus of resilient for the subgrade, which means the third layer. 71.45. How much is that? 71.81. Sorry. Okay. By using this, we can find the modulus of elasticity for the second layer. This you understood, no? I have simply applied it in the form of Excel form. The same formula. Don't get confused. Same formula. Uploaded by using Excel. So similarly, the modulus to find the modulus of elasticity of a GSP and WMM, I have updated a formula by using Excel. Only the thing is, okay, here is the formula is here for subgrade and GSP. The same formula I had developed in Excel and I had applied here. 0.2 into H into 0.42 to the power modulus resilient of the previous layer. So the combined thickness will be the 400. How much it will be? Modulus of resilient for the subgrade and for GSP and WM, it will be around 212.9. So I'm going to write this. Okay. After entering all these three values, let's go to Poisson's ratio. The Poisson's ratio we will be considering by using the same code book. The code book is very important here. Code book, with the help of code book itself, we are going to design the software. Here they have clearly given how much we are supposed to consider. Poisson's ratio will be considered using codebook. We need to assume it. Assumption needs to be made. That's for the Poisson ratio it should be around 0.35. So by assumption also, by codebook, with help of codebook also we are doing it. Okay, after entering the Poisson's ratio, the thickness here I will enter it as how much? 95, and here I will enter it as 400. Nothing, just I have written the combination, and I have added both VM and STBC layer, and I have written it as 75, and had added both GSP and WM100, and I have combined and written entered it as 400. Wheel load we will consider it as 20,000 Newton. Okay. Tire pressure will be about 0.56. Here he had mentioned single load for the purpose of calculation of the theoretical stress and strain. The single wheel load for 80 kilonewton will 20,000 Newton. So that's what I have entered here. Analysis point I will take it as 4 points needs to be analyzed for both 75 and 400 mm thickness. The rate, okay, I am writing it as 0. 75 I am writing it as 155. Now 75 0 475 155. Wheel load will be 2. Okay, now why I entered it as 75 and 0, why I had entered it as 475 and 0, let me explain. 75 means the combined thickness of both BM and STBC, and radial distance will be 0 for the initial distance. As it proceeds the 75 mm, the radial distance will be 155. This value how I entered here means that too by using codebook. See here, you had given it as mentioned it. The distance between two wheel will be around 310 mm. So half of that distance will be about 155 mm. See, it has the same distance between they had mentioned here. What they have mentioned? IITPAVE provides the option to carry out analysis of a single wheel load, 4-way the dual wheel load, set up 2 wheels at center to center spacing 300 mm by selecting 1 or 2 respectively. 300. The distance between 2 wheel load is 310 mm. So center to this distance, I need this distance, so I am taking it as half of that 310 mm. That will be 155. At this distance we are measuring the depth. Similar for 475, I am added these two for entire subgrade. And what is the amount of pressure we are experiencing, we will get that. So entire on the subgrade, the combination of everything, how much amount of stress or strain will be experienced by subgrade, this we are checking by entering the depth as well as the distance. The wheel setup will be the dual wheel load. So now I will submit. So you will see a message stating that values are successfully submitted. Click OK on that. Then you need to run. Okay, run. Then give. It is stating the values have been successfully done. So click on OK. So this window will be up here. So here you need to view results. It will be asked whether you need to open in file editor or in view here itself. This is back to edit. You can edit then. This is home. I need to view here itself. So you can see this all result you can see here. after seeing this, the negative values will be treated as a okay. So the results have appeared here. How to check whether you have done, how to check the results means, the negative values what I get, the greater of these values, so this will be treated as a horizontal. So this will be treated as a one sec, I'll let you know. Okay, here the EP is at EP is a horizontal. This will similar horizontal tensile strain. This will vertical compressive strain. So the horizontal tensile strain, which will be positive in nature. You can see the greater of these, the upper in the sense 75. That will be BM and STBC will be 0.369 to the power of e to the power minus 3, and for 475 that will be the vertical compressive strain, that will be negative. That will be the greater of that, that is minus 0.5319. So the values which we got from the IITPAVE should be lesser than what we do by using conventional method for checking the rutting and fatigue. This value should be lesser than the values which we get for rutting and cracking fatigue criteria. So guys, this is how we will analyze the or design the flexible pavement using IITPAVE software. If there are any sort of what I need to say, if there are any kind of suggestion which you need to give to me, or any or anywhere have done mistakes, please do correct the mistakes. So I'm just doing for the sake of learning, I'm doing it. So please correct me if I'm wrong, and please do suggest me if anything needs to be done with this video. Thank you guys.